created by Mindsticks Foundation Trust. Welcome to today's Explainer. We have a really fascinating journey ahead of us today. We're going to systematically explore how we generate power. We'll start by looking at natural gas power plants and the very real impact of fossil fuels. Then we'll shift our focus to the urgent transition to green energy, specifically diving into how we harness hydroelectric power, generate wind energy, and capture solar electrical power. Let's get started. Section 1. Natural gas power plants, a step up from coal. So natural gas is indeed a conventional fossil fuel, but it operates with much higher efficiency than coal. And here's the best part. Because natural gas doesn't contain sulfur, burning it creates significantly less pollution. It's quite a bit cleaner. Now, if we think about the mechanics of how this actually works, there are three main functional sections. First, a compressor forces highly pressurized air into a combustion chamber. Inside that chamber, the natural gas burns right alongside this pressurized air. This intense combustion creates a gas at an extremely high temperature and pressure, which then forcefully drives a gas turbine. And that turbine? It rotates the generator to produce the electricity we use every day. To make this perfectly clear, let's break down the exact step-by-step transformation of that energy. We kick things off with the chemical energy stored securely inside the natural gas. Through the process of combustion, this transforms directly into kinetic energy. That kinetic energy is then transferred to the gas turbine, becoming kinetic energy within the turbine itself. Finally, the generator steps in and converts this spinning, rotational movement into the electrical energy that powers our homes and our industries. To ground this theory in reality, we just have to look at the massive capacities of major natural gas power plants operating right now across India. For example, the plant in Samarakalta, Andhra Pradesh, boasts an incredible capacity of 2,620 megawatts. We also have highly significant, powerful facilities running in Anjanville, Maharashtra, and Bhavana, Delhi. Section 2. The impact of fossil fuels, the need for change. Now, despite the better efficiency of natural gas, generating electricity from any fossil fuel degrades our environment severely. It's a harsh reality. Incomplete combustion releases carbon monoxide, which is directly harmful to our health. We're also dealing with immense carbon dioxide emissions, which we know drive global warming. Burning these fuels generates nitrogen dioxide, which actually leads to the destructive phenomenon of acid rain. Plus, tiny soot particles get into the air and cause serious respiratory problems, like asthma. And beyond just the pollution, we have to remember, these are not endless resources. At our current rate of consumption, the world's coal reserves will be completely depleted in just about 200 years, and natural gas in maybe 200 to 300 years. Section 3. The shift to green energy, towards environment-friendly solutions. Section 4. Harnessing hydroelectric power, energy from flowing water. Water is incredibly powerful. To extract immense energy from it, water is stored in a massive reservoir behind a towering wall. This fast-flowing water is then brought from the middle height of the dam down through a special channel called a penstock. The sheer kinetic force of all that rushing water hits the turbine situated at the very bottom, causing it to spin rapidly and, you guessed it, drive the connected generator. The flow of energy here is actually quite elegant. Let's walk through it. We start with the potential energy safely stored up in that huge volume of water in the reservoir. When it's released and falls, it naturally converts into the kinetic energy of flowing water. This then transfers into kinetic energy in the spinning turbine, which the generator efficiently transforms into pure electrical energy. Now, as objective students of science, we always need to evaluate both sides of the coin. Hydroelectric power has some wonderful advantages. There's zero pollution from combustion, we can generate power completely on demand as long as we have water stored, and the monsoon rains naturally replenish our source every year. However, the drawbacks are substantial. The backwater from these giant dams can submerge entire villages, fertile agricultural lands, and dense forests, which sadly leads to the forced migration of displaced populations. It also heavily obstructs the natural flow of rivers, and that can deeply disrupt delicate aquatic ecosystems. To truly grasp the immense scale of hydroelectric adoption in India, take a look at these major dams. The Tehri Dam in Uttarakhand alone produces a massive 2,400 megawatts of capacity. The Koyna Dam in Maharashtra provides a robust 1,960 megawatts. These are absolutely monumental engineering feats that are powering large sections of our nation right now. Section 5. Generating wind energy. Capturing the breeze. Unlike hydropower, capturing the breeze relies entirely on specific geographic locations and wind velocity. When you look at the internal mechanics of a windmill, you'll see that as the wind strikes those large blades, they start to rotate. But here's the really crucial part: the gearbox connected to the main shaft. You see, those huge blades actually spin relatively slowly. The critical job of the gearbox is to dramatically step up those rotations per minute. This high-speed rotation is exactly what's required to efficiently drive the generator. It's a beautifully direct energy conversion process. We just need wind blowing at a specific, sufficient velocity. The kinetic energy in that blowing wind transfers directly into kinetic energy in the wind turbine, and the generator instantly does its job, converting it into electrical energy. The variance in turbine sizes around the world is just mind-blowing. Depending on the location, you might find small 2-kilowatt units with 1.5-meter blades powering a single home. But out in the ocean, where wind velocity is incredibly high and consistent, we install absolute giants. We're talking offshore turbines generating up to 7,000 kilowatts, using gigantic blades that stretch 100 meters in length. That's roughly the size of an entire football field, just spinning in the wind. Section 6. Solar electrical power. Energy direct from the sun. Solar is truly unique because it doesn't use electromagnetic induction at all. Instead, it relies on the solar photovoltaic effect. A basic single-silicon solar cell actually generates a very minimal amount of direct current. But by cleverly connecting these tiny cells in series to increase the potential difference and in parallel to increase the current, we create highly practical solar panels. Link many panels together, and you get a module. Link strings of modules together, and you've just built a massive solar array capable of generating megawatts of power. Now, I have to remind you of one absolutely critical step in this process. Solar cells naturally produce direct current, or DC. However, almost all the equipment in our homes and industries runs on alternating current, or AC. Because of this, an electronic device called an inverter is an absolutely vital component. It takes that solar DC power and converts it into the AC form that we can actually plug our appliances into. We should also briefly touch upon solar thermal power plants, which are a really important alternative. In this method, instead of using photovoltaic cells, we use concentrators, basically giant mirrors, to collect and focus sunlight. An absorber takes all this intense concentrated heat and uses it to boil water. The resulting steam turns a steam turbine, which then spins an electric generator. So it's actually very much like a traditional thermal plant, but it's powered entirely and cleanly by the sun's radiation. As we wrap up today's lesson, let's take a hard look at the data comparing India's energy mix against the global average. You'll immediately notice our heavy reliance on coal, a massive 60% in India compared to 41% globally. Our natural gas usage is much lower, sitting at just 8%. However, look at the renewable sources. This is where it gets exciting. India displays an impressive 15.7% adoption rate for renewables, far outpacing the global average of just 6%. We are definitely making significant strides in the right direction. But all of this leaves us with a very provocative question to ponder. With global fossil fuel reserves mathematically projected to run completely dry in roughly 200 years, is our current pace of shifting to green energy really fast enough to reverse the severe environmental degradation we are witnessing today? I ask you to think deeply about this. Thank you so much for joining today's Explainer. Keep learning.